Hi people, welcome to our channel. Today we'll discuss feature scaling. So I have an employee data set which contains three features: employee, age and salary. Age column ranges between 27 to 48 while salary column ranges between 47,000 to 78,000. Now it's clearly visible that there's a huge difference in the magnitude of both the features. So to overcome this, we need to perform scaling because in many machine learning algorithms, particularly distance-based algorithms like k nearest neighbor or support vector machine, which are sensitive to the scale of the input features. Hence, scaling helps to normalize the data and bring all values to a similar scale. So scaling is basically a subset of feature engineering where we standardize the independent features in a fixed range, which can be done using two techniques, normalization and standardization. So first, let's discuss normalization. It is also known as min-max scaling. Since it normalizes the data using minimum and maximum values, the whole purpose of normalization is to scale and center the data within a specific range, typically 0 and 1. Let's discuss this using an example. So I'm using the same data set of employee where we have age and salary column. So to normalize these values, we use this formula x minus minimum value of x divided by maximum value of x minus minimum value of x. So if we need to scale 44, which is in the age column, we can use 44 minus minimum value of x, which is 27, divided by maximum value of x, which is 48, minus minimum value of x, which is 27. So we'll have 0.80. So here you can see normalized age ranges between 0 and 1. So basically normalization scales the data within a range of 0 and 1. Now let's discuss standardization. It is also known as Z-score normalization. Here the goal is to transform the features so that they have a mean of 0 and standard deviation of 1. This makes the feature adhere to the normal standard distribution. Taking the same example, here basically we calculate the Z-score of each value. So if we take the salary column, the first value is 73,000. So if we need to scale this, we use this formula x minus mean of x divided by standard deviation of x. So the mean of salary column is 60,428.57 and standard deviation is 10499.75. Using this formula, 73,000 minus mean of x, which is 60428, divided by 10499, we can have 1.1973. So if you'll calculate the mean of standardized salary, you can have 0 and standard deviation 1. We'll see the practical implementation of feature scaling. So I've imported all the libraries and this is the data we'll work on. Here we have multiple independent columns and the target variable is to classify if the person will take the term deposit insurance or not. So basically, I have only taken two columns for the ease of understanding, balance and age. Firstly, let's see the description of the data. Here, mean and standard deviation are, for age, it is 40.93 and for balance, it is 1362. Standard deviation for age is 10.61 and 30.44. Now let's perform standardization. For that, we'll import standard scaler from sklearn.preprocessing, import standard scaler. And then I've stored that in a variable called scaler. After that, I'll perform fit underscore transform on the data df underscore subs. So these are the values which I have after scaling for age and balance. Now I've converted this into a data frame. You can see these are the scaled values. You can see scaling is done and the mean and standard deviation is 0 and 1 respectively. Now let's do this using min-max scaler. So I've done the same thing from sklearn.preprocessing, imported min max scalar, and then stored that in a variable called scalar, and then performed fit underscore transform in the data. These are the values, and then I've converted them into a data frame. Now you can see the value are ranging between 0 and 1 in both the age and balance column. And the mean and standard deviation is this. If you find this video helpful, don't forget to hit that like button and subscribe to our channel for more such videos. Thank you.